Okay, grade 12s, welcome. We are looking at the graphs of a function and their inverse. So hopefully you have done the pre-work to sketch the graphs. So the straight line graph that is given here is y equals 2x minus 4. It's labeled as f of x. And its inverse is y equals x plus 4 over 2. So let's just discuss how we get the inverse again. So we have y equals 2x minus 4. That's your original. So your inverse, you're going to switch the x and the y. Then you are going to algebraically rearrange and get y by itself. So we're going to move x across, and then we're going to get y by itself. And that's where they get that. All right, so then you can either use a table method or your calculator to plot them. But remember, once you've plotted the straight line graph, so that's why also there's points all over here. So that's your inverse graph. And then your straight line graph is this one over here. Right, so let's say you are going to plot the straight line graph using your calculator or using the table method, that the XY intercept method, however you want to. So you would end up plotting points. Those points, this is negative, this is 0 and negative 4. That's the y-intercept. So that will become the x-intercept in the inverse, because whatever is y in the function becomes x in the inverse. They swap around. And so if you notice, this point swaps around. This point was an x-intercept, now it's a y-intercept. These two swap around. It was 3 and 2, now it's 2 and 3. And if you swap 4 and 4, it's 4 and 4. So you literally just flip your x's and y's. You're swapping them. So you actually only have to plot one graph and then flip your coordinates and then plot them. Or again, use your calculator. It's up to you. So the line of symmetry, or the mirror line, is going to be your dotted line here, and your dotted line is y equals x. I'm hoping you remember that from your investigation. All right, so they could ask you to do the inverse or reflect it about the line y equals x. So this is just a summary of what I've said here. So your symmetry line is y equals x. They mirrored along that line. For every point on the function, it flips around on the inverse. Your x-intercept of your function becomes the y-intercept of the inverse, and the y-intercept and x-intercept are also switching around from that perspective. And if you have a graph where you have a x and a y point that are equal, they will intersect at that point. Okay, so this is just a set of points that you can apply to any function and its inverse. Now here comes the parabola. The parabola is a bit of a problem because the parabola in its original form is a function. If we work with the vertical line test, it only cuts in one place. And it's a many-to-one function because when we do the horizontal line, it cuts in two places, which means that two x values share the same y value, which is fine. Right? It's when you have the same x value with multiple y values that it's a problem. And that comes in when we look at the inverse of it. Okay, because then the inverse of that graph, right, as soon as you do the vertical line test, it cuts in two places. So we're going to come back to that issue, but there's a bit of a problem here. Okay, so if you have a happy parabola, its inverse will be a parabola to the right. If you have a sad parabola, its inverse will be to the left. And the symmetry line is still the same. It's still the line y equals x. Imagine, I can't do this right now, but if you had a piece of paper, folding over that line, those two graphs are going to sit on top of each other. Right, and very specifically, this arm here reflects to this one because that one's a positive x value, so that's still going to be the positive arm. And then this arm over here is in the negative x values, so it's going to go down to the negative y values. So negative x becomes negative y. Remember, x and y switch around in the inverse. So let's think about the equation of the blue graph. It's y equals x squared, basic parabola. So if I'm going to invert it, right, find the inverse. What's the first thing I need to do? I need to make x and y interchange. Then algebraically we're going to get y by itself. So y is equal to plus minus the square root of x. Please just note, often they will show you a little restriction here that x cannot be negative. It must be greater than 0 or equal to 0. All right. So just make sure that you don't get a negative under a root sign ever. The negative in front here is not a problem because that's talking about outside of the root sign. Okay, so this is also something that you'll be able to study off by heart. The only thing that might change is if you get something like y equals 2x squared. So then it's x equals 2y squared. Switch around. And then you get your y by itself and then square root. Alright, so then you end up with a different look under the square root sign, but it's still going to be plus minus a square root. So it becomes from a parabola almost to a square root graph as such. Alright, so here's an example. Given the function y equals negative 2x squared, determine the equation of the inverse of this function. So let's just do this here. So for a, let's just call it my function is y equals negative 2x squared. So my inverse is going to be x equals negative 2y squared. So all I've done is where I see a y, I put an x, and where I see an x, I put a y. Then algebraically, I move it around so that we end up with y by itself. So this is going to be x divided by negative 2 is equal to y squared. And then I'm going to get y by itself by square rooting. Alright, so then we need to sketch the graphs of y equals negative 2x squared and its inverse on the same set of axes and show the line of symmetry. So this one, hopefully you've tried it on your own, and then if you're not sure, either use your calculator or use the table method for coordinates of plotting graphs. Because we have a negative 2x squared as a graph, it's going to be a sad parabola. So based on what I said earlier, we can predict that we're going to have a left-hand inverse square root graph. Right, so try and predict what your graphs are going to look like before actually sketching them. So if it comes out weird on your calculator, then at least you can fix it. Okay, so I'm just going to plot this for you. Okay, so I've plotted the sad parabola. The inverse will come now. This is a concave down parabola or a negative parabola. And so what I did is just used the negative 1, 0, and 1, 3 points, and then I put it into the original equation and got my y value. So they are the coordinates that I plotted. So then now for your inverse, you just have to flip your x's and y's. So this was negative 1 and negative 2, so it will become negative 2 and negative 1 for your inverse. That will stay 0 and 0, and that will become 1 and negative, I wrote that wrong to start. There we go, fixed. So this will become negative 2 and 1. Alright, so let's plot that. So we have x is negative 2, so I've got to get a negative 2 to go with negative 1, 0, and 0, and then negative 2 and positive 1. And there's the graph. Alright, so if you could imagine what it's going to look like, you don't have to use the points, but the idea is to sketch, so we don't want full-on plotting. But if you can't sketch it, you can't imagine it, then you can use your calculator or your table points. And then we're going to work with our line of symmetry. Please use a ruler. That is y equals x. All right, so your line of symmetry is always y equals x for an inverse graph. Then for your exponential graph, for example, y equals 2 to the x, will then become what we call a log graph, which I'm going to talk about a little bit more on the next few slides. So for now, just work with the idea of y equals 2 to the x. We need to work with the inverse. So first let's plot this. So when you're plotting an exponential graph that has a base that is greater than 1, then it's always going to be an increasing exponential graph. And because there's nothing added or subtracted, it's going to cut at 0 and 1. Right, so if you're using your table method to plot this, it's going to be your x values, -1, 0, and 1, or in your calculator, just use those points. And then you're working with your original equation is 2 to the x. So 2 to the negative x is a half, 2 to the 0 is 1, 2 to the 1 is 2. And that's where these points came from on the graph over there. All right, so then for its inverse, all you have to do is flip them around. So that becomes half and -1. That becomes, instead of 0 and 1, it becomes 1 and 0. Right? 1 and 2 becomes 2 and 1. Again, our symmetry line is running straight through y equals x. And the reason it's y equals x is because that's 0 and 0, 1 and 1, 2 and 2, 3 and 3. The y and the x value are the same. All right, then just remember your asymptote for your original exponential graph is going to be the x-axis. So the inverses is going to be the y-axis, because whatever's x becomes y. Also have a look here. Our graph was going upwards from left to right, and it was approaching the negative x-axis. So then for my the inverse graph, it's still going to be going up from left to right. Okay, but it's approaching the negative y-axis, because remember, anything x becomes y in the inverse. Okay, so let's talk about the equation of the inverse. So we have y equals 2 to the x. That's the original f graph. So our f -1, take y, make it x. Take x, make it y. Then get it by itself. Now, when you're trying to get an exponent by itself, look for its base. Its base is 2. So we're going to have log base 2. The y was with the 2, so now the x needs to get its chance to be with the 2. 2 wants its x back. All right, and then remember the asymptotes switch around. So that's summarized over here. Okay, if we have a look at a graph of g of x equals to a half to the power of x, that means your base is between 0 and 1, so it's a fraction. And so when it's a fraction, look what happens. Our graph goes downwards from left to right, and it's approaching the positive x-axis. So what's our inverse going to do? It's also going to go downwards from left to right, but it's going to approach the positive y-axis, because everything x becomes y. Once you're plotting the red graph here on your calculator, just remember, once you've got your points, you can then just flip them around. So invert them, flip the x and y, and you can plot. And then our mirror line here. All right, so then getting our equation, we know we make y equal to x and x equal to y, and then to get the y by itself, we keep the base of the exponent and it wants its x back. Right. So it says here, note that the inverse graph of the exponential graph is called the log graph, logarithmic graph. If the exponential graph increases, so it goes up from left to right, then the log graph also increases. So that is an exponential graph that has a base greater than 1. So 2, 3, 4, 5. I'll explain that a bit more on the next slide. If the exponential graph decreases, so goes down from left to right, then the log graph also decreases. And that is when your base is between 0 and 1. So like a fraction, like a half, a third, a quarter. Please remember to learn the shapes of your graph. It helps you a lot. So just to conclude and just to recap of this idea now. So the inverse of an exponential function is known as a logarithmic function, or a log graph, or a log function. And it's our reflection of our exponential graph over the line, y equals x. So we get two types of log graphs, but remember they come from two types of exponential graphs. So we're going to I'm just going to draw this one here. We get an increasing exponential function, for example, y equals 2 to the power of x. It's where your base is going to be greater than 1. And then you get a downwards or a decreasing exponential where it goes downwards from left to right. And that's when your base is going to be between 0 and 1. So we have something like this, y equals a half to the power of x. It could also be a type of a reflection, which we'll get to a bit later, where it's actually 2 to the negative x, because remember that is 2 to the negative 1 times x. 2 to the negative 1 is a half. Alright, so we could end up getting that negative exponential from a reflection, but that's going to come in a later part. So when we're converting our exponential into our log graph, we keep the same base. So our base, let's say, is a here. Our base in this type is going to be greater than 1. And so the base of the exponential stays the base of the log. So let's say it's a to the power of x. So that's the base of the exponential, becomes the base of the log. And then we're going to then use our x's and y's. But remember, we've got to invert it first. Okay, so when you have a graph, let's say this one's called f of x, and then this is f negative 1 of x. Let's take it back to our 2 to the power of x. Right, so remember, we're going to switch x's and y's. So for y, it's going to be x equals 2 to the y. So you switch the x and the y, and then you've got to get y by itself. So the base of my log is going to be the base of my exponent, and then you get the x with that log, and you get y by itself. All right, so that's your general rule there. So then now for an increasing exponential, it goes upwards from left to right. It approaches the negative x-axis. So then if we look at the log function, it's also going upwards from left to right, but it's going to be approaching the negative y-axis because x becomes y. They switch around. The y-intercept of this graph is 1, so it becomes the x-intercept of my log graph. Then for my decreasing function, can you see for my exponential, the inverse is going to be decreasing as well. Here it's going to approach the positive x-axis. Here it approaches the positive y-axis. Y-intercept is 1, so here our x-intercept is 1. The x and y switch around. Okay, so you can study the way the graphs look. It just makes your life a little bit easier than having to plot from your calculator every time. You can sketch it quickly. Right, and don't forget that this is a reflection about the line y equals x. So let's draw in the original exponential. So this one's going upwards. Sorry, it's not the best color. Upwards, and it's reflecting in this line. So imagine folding over the blue line. The black would end up falling onto the purple. And then on this side, it originally came from a decreasing one. and it's going to go through the line y equals x. Alright, so you can imagine trying to fold them over. So the increasing log graph comes from an increasing exponential and decreasing from the decreasing one. Alright. Don't forget x-intercepts and y-intercepts will swap around. So if it was a y-intercept in the original, it's going to become an x-intercept in the inverse. And then your asymptotes go from the x-axis to the y-axis asymptote. Just a big note here, please. This graph is very deceiving up here. Both of them. The graph looks like it's touching the axis, the asymptote. It's not. It's just the software draws it sometimes that it's touching it. So please make sure you don't let your graph, not even the arrow, touch the asymptote, please. Right, then you can get on with exercise 2. You're determining the equation of the inverse of the graph and then sketching its function and inverse on the same set of axes. And please don't forget your line of symmetry, your dotted y equals x line. We are going to come back to some of these a little bit later in some videos, specifically looking at reflections and application of graphs and dealing with problems and exceptions. But for now, just try and work on these. And just referring to the parabola, remember we said the parabola has this graph that's not an inverse because of the vertical line test. So we're also going to come back to that and what that means and the problems that come about from that. All right, so let's keep it simple for now.